Hello friends, welcome to physics class. Today we will discuss the chapter Newton's law of motion. We will also discuss the MCQ questions as per the exam point of view. So in the Newton's law of motion, first thing comes in our mind is force. What is a force? Force is an external effort, that is either it is a pull or push. Whether we can push an object or we can pull our object. So what things are associated with it? First is it tries to produce a motion, a body at rest. Second thing, stop or tries to stop a moving body. Third thing, changes the direction of motion of body. If we see its example, a football is placed here and a player P1 applied a force F1. So ball starts moving towards the another player P2. This P2 player needs to stop the ball, so some kind of force F2 he applied on this football so that body will come to the rest, or he changes the direction of football to another player P3 and the P3 player stops the ball with the force F3. So that means the force is external effort, pull or push. Either you can make the football which is initially at rest move it towards the player P2, and after stopping this ball it is moving with some kind of velocity, but the player P2 stops it, and again the final condition, initial velocity gets 0, again we apply some kind of force to it. So there are a lot of examples of this. When we push a ball lying on the ground, or we throw a stone, or when a piece of stone is tied to one end of the string and whirled in a circle, a constant force has to be exerted by the hand along the string. Once we stop, it will not stop moving, it will move tangent to the circle. So these are the things associated with the force. So how this process started? It started with the scientist known as Galileo. Is known as Galileo's law of inertia. Galileo did some kind of random experiments in which what he observed that the objects moving down a smooth inclined plane accelerates. For example, a ball kept at an inclined plane. Here we kept an inclined plane. This is a smooth surface, so ball starts rolling in the downward direction. Or he keep the ball at here top, the ball start retarding downward. Then he took one of the frictionless surface, the surface which has no friction. Then the ball starts moving on a frictionless horizontal plane, moving with a constant velocity, have acceleration and no retardation. And the ball starts moving in a particular direction. So what experiment he did? He took that kind of container or a surface. Here he took the ideal condition. The ideal condition was this surface is a frictionless surface. First condition is that it is a frictionless surface. No air resistance has been determined here. So what happened? First thing, what happened in an ideal situation, there is a no friction. He throw the ball from this side and ball starts traveling and reaching the final destination. But if we do practically, if we throw ball from this side of container, the ball will not reach the same height. Reason is friction and also the air resistance. But in a frictionless surface, ball reaches the same heights as initial and as well as final. So while conducting this experiment, secondly what he did, he changed its slope, increased the distance of the slope, and throw the ball here. The ball starts moving from this direction and reaches the same height as again the initial height, because the surface is a frictionless. Again what he did, remove the slope and make it horizontal, so the ball start moving to an infinite horizontal surface. So this kind of experiment he did. From the experiment what he concluded, the state of rest and state of motion with the constant velocity are equal. In both cases no net force is acting on the body, but the Galileo thinks at that particular point of time. So this experiment, study the motion of object on an inclined plane. Second thing, objects moving up on a smooth inclined plane retarded. Object moving on a frictionless surface horizontal plane moving with the constant velocity have neither acceleration and nor retardation. So what conclusion he observed, if a net external force is 0, if our F external is equal to 0, a body at rest continues to be at rest, and a body in uniform motion continues to be in the uniform motion. So basically he observed this kind of things with this experiment. Next we discuss the linear momentum. What is a linear momentum? The linear momentum of a body is defined as a product of mass into velocity, m into v, that we have seen in this formula. So what is a linear momentum is also called as a vector quantity. It has magnitude as well as direction. What is the dimensional formula? That is MLT inverse. Remember it thoroughly. What is its SI unit? Is kg meter second per inverse. So as we discuss here, the linear momentum is equal to mass into velocity. For example, a body mass m, this is an object having mass m moving with the velocity v, has a linear momentum, that means it is p. Linear momentum also is a vector quantity. As I have already discussed, is SI unit is kg meter per second. Also in CGS unit of linear momentum, it is gram centimeter second per inverse. Also is dimensional formula I have already discussed. For example, here if we conclude P is directly proportional to V, if we have taken the m constant, what graph we observe between the linear momentum and velocity, that if m is constant, it is a straight line from the origin. If we consider here the velocity as constant, then here what you can see here, that v is constant. If mass is constant, here it is linear, and if here velocity is constant, it also acts as a linear. It is between the linear momentum and the mass. For the two bodies, let's take two bodies of unequal masses. For example, m1 and m2, they have unequal masses. So what happened with this? We have same linear momentum, that is p1 equal to p2. We will equate this equation, we will get v2 upon v1 upon m1 upon m2. So what we see here, the velocities of the body having equal linear momentum varies inversely as their masses, that is heavier body have smaller velocity and lighter body have great velocity. If a body having mass heavier, it has the smaller velocity, and a smaller velocity has smaller or lighter body has greater velocity. So these are the things with that. For example, if we consider a truck has having more force is required to push, but in case of car, less force is required with respect to truck. The car can move faster, but eventually they can reach their momentum very fast. So now we will discuss the Newton's first law of motion. According to this law, a body continues to be in state of rest or uniform motion along a straight line unless it is acted upon by some unbalanced external force to change the state. For example, an object mass m, we are applying some kind of force, and this object will move in this direction or in the continuous direction unless until external force is applied on it to stop this object. So it states that if it is in rest, it will remain in the form of rest. If it is in the uniform motion on a straight line, it will not stop. It will only stop when an external force F is applied. I have also taken the example of football. When we kick the football, it will start moving in the direction unless it is stopped by some another force. Assume that the surface is frictionless. Otherwise, due to the friction, the ball will get stopped. Newton's second law. The rate of change of linear momentum of body is directly proportional to the external force applied on the body, and this change taking place always in the direction of force applied, that is force equal to mass into acceleration. A body mass m, when we apply a force, it will accelerate in the direction, it is directly proportional to the force applied. Third law we have discussed, to even action there is always an equal and opposite reaction. The force of action and reaction are always equal and opposite. As you can see here in the diagram, here a rocket is here, it is applying equal force, it is applying thrust here. The cryogenic engines provide thrust here, so it has equal reaction until unless fuel is there. So this fuel is providing that kind of thrust, same as like the cryogenic engines. This thrust is provided, action equal to the equal and opposite reaction. So we will discuss this in detail in